my name is Lori, and I work for the Cass County Soil Conservation District as Watershed Coordinator.
Hi, my name is Courtney. I'm the Urban Conservationist for the Cass County Soil Conservation District.
Today we're going to demonstrate how to use a stream table. A stream table is a very valuable tool when teaching all ages. Kids in school as well as adults can learn from a stream table. And a stream table is basically a slanted piece of equipment that holds water and sand and soil-like particles. It's the appropriate size, so it acts like real soil out in the environment. So you can see hundreds and hundreds of years of fluvial processes in a matter of minutes. So people can learn how a river acts, how it forms, how it moves, how it changes over time. And they can also learn how to interact and manage a river based on how it functions.
In addition, the stream table is really effective in showing the value of well-vegetated banks and the value that has for protecting wildlife, aquatic life, and personal property. In addition to that, it's really important for people to understand, students and adults, to understand the processes and how a river system works, because through that we can better improve our urban watersheds as well as make better decisions for those watersheds.
So when you start out with your stream table, you're going to want to make sure that all the soil media is wet. It's very sticky when it's wet, but it's plastic, so it doesn't, it keeps the water clean. You can start out with a straight channel, or you can make a curved path. Rivers normally are going to flow in a curved path, like an S or a C. When I'm talking to kids or adults about streams, I often try to have them visualize the sea, if they can see C's in the form of the river. And then when you see the sea, you say that the outside of the sea is the cut bank or the outside bank. And the inside of the sea is the inside bank or the point bar. The cut bank is normally where you're going to see the most erosion. And erosional processes are just the movement of sediment from one place to another. And streams are always moving sediment downstream. So there's always more sources of sediment upstream, and that continues to move downstream. And if you change the amount of water or the amount of sediment, you're going to change how the river is formed and how it forms in the future. It may degrade and go down, or it may aggrade and the bottom may come up. So it's always important to have sediment in the river in the appropriate amounts. But if you see closely, you can turn the water up and down usually. And you can see the particles moving. And you'll see the cut banks where the soil is cutting away. And usually you'll see deposition or particles being deposited on the point bars or the inside bank. Now this demonstration right now, we don't have any bank armoring, so the sediment is free to move, and if you had bare soil in a native environment, you would have a lot of erosion as the water moved the soil with the river. Another feature you can see coming in down towards the bottom of the stream table is the formation of a delta, and you can see how it starts to fan out and form a delta just like it would down at the end of a stream. So some of the features we're looking at on a stream would be, starting at the bottom, you'd have the delta formation at the mouth of the river. As you move up, you would have these meanders or curves with the cut banks and the point bars. And then you will have, at the top, you'll have the headwaters where the river begins. You might also have tributaries coming in. Those would be smaller rivers joining up with the major river. So an interesting part about cut banks and point bars is that the fastest spot in the river, also where it's also the deepest, is called the thalweg. And the thalweg follows just outside of the cut bank where it's going the fastest. It just bounces right off of there. And then the thalweg crosses where the stream is straight. and it crosses over to the other cut bank, the outside bend. And it crosses again here and comes back and just follows that pattern. So you can use colored water with food coloring in it to really get a good idea of where the water's flowing in that river. Because even though there's water moving through the whole river, a large majority of it is flowing in the Thal Lake. You may hear the term pools and riffles, and you'll get pools off the cut bank where you'll have a little bit of more erosion happening. So you might have a deep hole there where you'll have a pool, and then it'll shallow up, the bed will come up in the straight sections, and you'll get riffles there. So you might have a lot of sediment moving out of the pool and then being deposited in the straightaways. On a broader scale, the area around a river is called the riparian area. The river channel itself is between the banks, and that's where the water is flowing most of the time. When the river gets to bank full, that's the top of the banks. So once it gets to bank full, if it gets any higher, then it spills out onto the floodplain. And the benefit of it spilling out onto the floodplain is that water is very constricted in the river. So it's moving fast and it has a lot of power. When it spills onto the floodplain, it releases some of that power, it slows down, and you get more deposition and less erosion in the floodplain. But the floodplain itself is at the elevation of bank full, and then as far out as the river will go when it's flooding.
So a lot of times when I go to schools, these terms are new to students. So we try and just really get them to learn and take in all of these terms and at least try and go home with a couple of them. So I really like to focus on the basic terms. So I'm going to go over some of these using these plastic words, which really do help, and sometimes it's really beneficial to have the children actually put them into the table and giving each student one of them or groups of two, and they can put in the table. So we talked about channel. We'll put that in here. Hopefully it won't float away. It might, and that's okay. That's our channel. It's a stream area in between the two banks. We talked about the headwaters. The headwaters are up here at the beginning, or the source of the river. We have the mouth of our river, which is down at the end of the river where it empties. We have a delta at the mouth of the river, which can cause new land, or where the river flows out in like little fingers. We have our meanders. We talk about our C or S-shaped meanders. I like to call them the squiggles, and kids remember the squiggly kind of snaky river. Put that here. Of course, our banks. Students see a lot of erosion. Usually I'll have them put this one on the outside bend of the river, since that's where the most erosion will occur and where the river moves the fastest. So there's an outside bend there. And we have the word outside bend. Our riverbed is the bottom of the river, and we'll just stick that underneath there. We have our point bar, which is on the inside bend. So we have our point bar and our inside bend. The point bar is down there. There goes our channel, down the channel. We have a tributary. In our model here, we don't really have a tributary, but I like to explain those as kind of the arms of the river. And our floodplain on the flat sides of the land beside the river, and our riparian area. The area right beside the river, which we like to talk about the riparian area for the value that it has for wildlife, for recreation, for aquatic life, and for the health of our water.
So after we've covered the basics of a stream and how it functions, kids really have, and adults have, a really good idea of how a river moves. And you can see as our river's been changing since we've had this discussion, the river's gotten wider. The channel itself has gotten wider. It might have gotten a little shallower in some spots, deeper in others. And it's also starting to meander further and further. So these S's and C's are getting smushed and elongated. The river will actually cut that off, and you'll have a straight section there, and then you'll have an oxbow. and eventually the river will start to meander again. Rivers usually meander. They don't like to stay in a straight line. So after we've talked about all this, the kids or adults have a really good idea of how to manage a river. So then we bring out all our little toys to show kids how they can manage their river.
One thing I really like to tell students is as they get their toy, they have to make a conservation choice for the rest of their students. Everyone lives in the town where the stream table is, and they have to use whatever item they have to make their best conservation choice. And one of the big ones that we talk about is vegetation. We like to talk about fortifying our banks with vegetation. Most students already know the principle that plant roots will hold the soil, so they really like to apply that knowledge. If not, we usually will show them a poster that has different root depths, and so they can kind of understand which types of plants might be best for riverbanks and which types of plants might not be such a good choice. Oftentimes we like to have students kind of figure out where they want to put their own things. And a lot of students actually really pick up, one thing I've seen a lot is they really pick up on the fact that the water moves fastest on those outside bends. So they like to put their plants on the outside bends. So I'm going to put some plants over there.
It's also neat, once you have a lot of this stuff in place, is to let the river change and flow and then start removing some of the items and see how the river depended on those items to stay in place. Because if you start removing things, the river's going to change. Water, you can't change one spot on a river and expect everything else downstream to stay the same or upstream. A river is very dynamic, so if you make changes upstream or downstream, it's going to affect the entire river.
The two most popular items that are often fought over are the homes. Generally, students in our area know where to put the homes. A lot of times they'll put it in the exact place where they know it's going to fall in. But we do like to go over whether it falls in or not, where a safe place for a house is and where a not so safe place for a house is. So usually I'll designate one of them my safe house. So today this black one will be my safe house. And so I'll ask students where they think I should build my safe house. Should I build it on the inside bend or should I build it on the outside bend? We like to talk about, after students have selected the inside bend, whether I should build it right here or whether I should set it back a distance so it has more protection from rising water. And then usually students will put a not so safe house, and we're going to put it on that outside bend over there.
So another thing you can talk about when looking at the stream table is surface flow, groundwater flow, subsurface flow. So when you're looking at the stream table, if the kids dig down a little bit, they'll notice that even land that's not in the stream bed may be wet further down. And so you can talk about groundwater flow and how the surface is connected to groundwater. And how important it is to keep our surface water clean to help with groundwater flow. Another common practice is to dredge a river or take sediment out. Oftentimes the river may be A-grading, the bottom of the stream may be A-grading up. And so you'll come in and you'll take sediment out of the river as a practice to clean the river of its sediment. Keeping in mind that rivers need sediment and water to function. And as you do this, you'll notice that it's changing the flow, and it's changing how quickly the sediment's moving. When you take sediment out, and if you take too much out, the river becomes starved for sediment. So it's gonna want more sediment, so you're gonna have more erosion taking place because it wants to be at that equilibrium of sediment and water.
So stream tables are really great for demonstrating to students how exactly a river flows, but also all of the different things that can impact a river. It's really great for students to actually see it. They read it so much in books that they know the words, but they don't actually know what the words really look like or how those words actually interact and function throughout the river system. So one thing I really like to tell teachers is, although we have all the things that we set up here, really be creative in what you do. There's so many different options, and I've heard so many people with great ideas. There's just so many things you can do and get creative. A lot of these things are, like Lori had said, aquarium toys, or from a toy store, just, you know, little plastic cows that you probably have around anyhow. So you can really put a lot of things into the table and have a lot of scenarios, whether it be an urban scenario or a rural scenario or whatever you want.